Welcome to True Projects. In this video, we are going to explain about a project titled Facial Expression Recognition using a Temporal Ensemble of Multi-Level Convolutional Neural Networks. The prevailing trajectory not only involves simplifying the human-machine interaction, but also imbuing machines with the ability to perceive the human emotion. The scope of identifying the human emotions encompass the facets like facial expression, vocal cues, and the bodily gestures. Among these, facial information stands a prominent choice due to its ease of acquisition and the immunity to issues like noisy auditory environment too. However, recognizing the facial expression remains the complex attributed to diverse head orientation and the background. The significance of deciphering the human emotions with the human-machine interaction systems is paramount, coupled with the persistent challenge posed by intricate head poses and the contextual backdrops and the facial expression recognition. To address this, we advocate the adoption of the deep convolutional neural network for the facial expression recognition in the real-world scenario, thereby empowering the missions to respond akin into the individual human beings, thus enriching the unconstrained human mission dynamics. And we present a novel two-stage approach to identify the facial expression from a sequence of images, aiming to capture the dynamic nature of human emotions, and this initial stage, facial regions within each frame are meticulously extracted, subsequently capturing the vital emotion-related cue. These extracted features are then treated as the temporal data, contributing to the categorization of emotions into the 7 fundamental categories. Moreover, our study delves into the multi-level features integrating with the CNN for the highlighting of the facial expression recognition. To enhance this task, we introduce the diverse network connections, augmenting the model's ability to discern the intricate emotional cue. Through the rigorous evaluation, our proposed method demonstrates the remarkable performance, surpassing the existing techniques on the dataset and even outperforming the sole architecture of the emotive challenge vector. And the basic requirements that are needed to build this project are software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. And the first one is importing the packages. The project commences by importing the essential Python packages, libraries, and the frameworks necessary for the data manipulation, visualization, image processing, model construction, and the evaluation. And the second one is exploring the dataset. A comprehensive exploration of the facial expression dataset is conducted. This phase involves in-depth analysis of the dataset characteristics, distribution, and the potential challenge, which informs the subsequent pre-processing steps. And the next one is of image processing. 8 techniques are employed to enhance the quality and extract the relevant feature from the facial images. This method might encompass the operations like noise reduction, normalization, and the feature extraction for the subsequent analysis. And the next step is data extraction from the image. The project extracts the pertinent information from the facial images, focusing on the key features that convey the emotional expression. These features form the foundation for the subsequent model training and the prediction. And the next step is splitting the data into the training and the testing. The dataset is divided into the training and the testing subset. The trained data is used to train the model, while the testing data remains untouched until the model evaluation stage. And the next step is of building the model. Here various models are developed. The first one is of LRCN, long-term recurrent convolutional neural network using the PyTorch. It is a fusion of CNN and RNN designed to capture both the spatial feature from the image and the temporal dependency over the sequence. In this project, LRCN leverages the PyTorch to analyze the sequence of the facial images effectively, considering the evolution of the expression over the time. By combining the CNN and the RNN, LRCN achieves an advanced level of emotion recognition too. And the next one is MobileNet. It is a lightweight CNN architecture optimized for efficiency in the terms of computational resources and the memory usage. In the context of facial expression recognition, MobileNet demonstrates the rapid processing and accurate prediction of emotions. Its streamlined design makes it suitable for the real-time application while maintaining the competitive performance. And the next step is VGG phase. It is derived from the VGG architecture and is specially designed for the face-related tasks. It excels in capturing the intricate facial feature and nuance that convey the emotions. This model deep layers facilitate the hierarchical feature extraction, enabling it to discern the subtle expression changes and provide the comprehensive emotion recognition. And the next one is ResNet. It is known for its residual block, which mitigate the vanishing gradient problem and allow for the training of very deep network. And this project, the ResNet depth empowers us to identify the intricate pattern and the minute changes in the facial expressions. And the next one is GoogleNet. It is celebrated and it is attributed making it proficient in recognizing the complex facial pattern indicative of emotions. In facial expression recognition, GoogleNet's multiple scale analysis contributes to the enhanced performance and the robustness. And the next one is MLCNN. Multi-level convolutional neural network operates by employing the multiple convolutional pathways of varying depths, extracting the multi-scale feature from the facial images. In the context of the emotion recognition, MLCNN diverse perspective allow it to capture the intricate cues from the different spatial resolution, enriching its ability to discern the emotion. And the next one is MLCNN plus GoogleNet. By combining the MLCNN with GoogleNet, the model harnesses the strength of both the architectures, the multi-level feature from the MLCNN and the intricate pattern recognition of GoogleNet unites to improve the emotion recognition accuracy. And the next one is CNN. It stands for Convolutional Neural Network. It serves as a benchmark, and this project it is specialized as of not as other models. It demonstrated a solid foundation for the facial expression recognition. It employs the convolutional layers to identify the spatial features, contributing to the accurate emotion prediction. And the next step is the user gives the input. A user-friendly Flask interface allows the user to input the facial images for the emotion prediction. And the next step is the given input is pre-processed for prediction. User-provided image undergo the pre-processing, encompassing the feature extraction and formatting the rendering them suitable for prediction by the trained model. And the next one is of the trained model is used for the prediction. The trained multi-level CNN model analyzes the pre-processed input to predict the corresponding facial expression, considering the temporal dependency and the multi-level feature. And the last one is final outcome is displayed. The model's prediction outcome is showcased to the user via the Flask interface, and this output includes the information of the facial expression predicted with it. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The data folder containing of the various folders containing of various images within it. And the sample folder containing of the images that will be used for testing the performance. And the static folder containing of the folders like of CSS, JavaScript, images, and assets, bootstrap files within it. The template folder containing of HTML documents, it typically include of form, notebook, sign-in, sign-up pages within it. And the testing and training folder containing of the images with it used for the testing and the training purpose. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. and the model files contain the information of the algorithm and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code and the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it changes the country directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this local path and paste it on any of the web browser, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we redirect to the page containing of the title and some information about it. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here redirected to the sign in page containing of the username and password and those details that are need to be entered, and then click on the register button. Here we redirected to this page containing of the choose file and the submit button. Then click on the choose file button. Here it will redirect it to this folder containing of images within it, and select one image and then click on open button and then click on the submit button. Here the predicted image as of given the expression as of here, and by using the try again button, here we redirect it to this index page, and by clicking on the choose file button we upload the other image and then click on open button and then click on the submit button. Here the expression for this given input image is classified as sad. In this way we can recognize the facial expression by using various deep learning models. And in conclusion, the findings of the study which investigate the hierarchical feature in the CNN for the facial expression recognition. We propose a single ML CNN that automatically selects the important mid-level and high-level features based on the contribution and outperforms the single and ensemble models on the FER 2013 testing set. We also propose an ensemble model by combining the ML-CNN variant which achieves the competitive performance and is promoting the method for facial expression recognition and the while. The temporal model, whose backbone is of proposed ensemble of MLCN, also achieved the comparable performance and outperformed the other single video mobiles of the recent winners too.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.